Hello everyone, in this video we'll be solving problem 167 to sum part 2. Input array is sorted. The problem statement is we are given one indexed array of integers numbers and a target. We need to return the indices of two numbers whose sum is equal to the target given to us. Another information that is given to us is that there is exactly one solution. So there cannot be multiple pairs whose sum will be equal to the target. And we cannot use the same element twice. So we cannot use 3 plus 3 to get the target of 6. As a follow-up, we need to implement a solution that uses constant extra space. Looking at example number 1, the input given as 2, 7, 11 and 15 and the target is 9. There is only one pair giving us the total of 9, which is 2 and 7. Hence the output is 1, 2, which are their corresponding indices because it is one index. If it was 0 indexed array, the output will be 0, 1. Similarly, in example number 2, the input given is 2, 3 and 4 and the target is 6. By adding 2 and 4, we can get the target of 6. So output is 1, 3, which are their corresponding indices. I hope you were able to understand the problem statement. Let's switch to whiteboard and discuss a couple of approaches, starting with the naive or a brute force approach, after which we can discuss the optimized one. Let's use this as an example. In the brute force approach, we will run nested iterations to iterate through the given array. The first iteration will be pointing at number 1, while the other will be pointing at number 2. Add the values that each pointer is pointing to see if it is equal to target. If yes, then we'll stop the iteration and return its corresponding values. If no, then continue the iteration until the end. With this approach, we'll be doing all possible combinations to check for the sum being equal to target. For example, we'll start with I pointing at 2 and j pointing at 7. We'll compare its total against the target. If it matches, that's great. Else, we'll increment the j pointer. So after 2 and 7, we'll compare with 2 and 11, then 2 and 15. Once this is done, we'll increment our first pointer to move to 7. Now the next comparison will be from 7 and 11, 7 and 15, and so on and so forth. With this solution, our time complexity is O of n square because we are running nested iterations, and the space complexity is O of 1. As we are not maintaining any collection, we are simply adding two numbers and comparing it with the target. As you can see, the time complexity is super high and can grow exponentially if the size of the array increases. So now let's think about how we can optimize this solution. Another way to solve this problem is by using a two pointers approach, where the first or the left pointer will be pointing at the first entry in the array, while the second one will be pointing at the rightmost. The idea is to effectively increment or decrement the pointer's value based on the sums that these two numbers are pointing at. As it is given in the problem statement that the array is sorted, we can use the value sum to determine if we should be incrementing the left pointer or decrement the right pointer. There are a total of 3 scenarios which could happen when we are comparing two values, that is sum and target. Sum is equal to target or greater than or less than the target. If the sum is equal to the target, it means we found the pair whose sum is equal to the target, so we can stop the iteration and return its corresponding indices. The next case is where sum is greater than the target, which means we need to change the number so that we can bring sum closer to the target. Because the right pointer is pointing at the value which is higher compared to the left pointer, we need to decrement the right pointer so that we can use the next biggest element in the array for calculation. The last case is where sum is less than the target. So to bring the total closer to the target, we need to use a bigger number. As the left pointer is pointing at the leftmost element in the sorted array, which is always going to be smaller, we can increment the left pointer so that we can use a bigger number for calculating the sum. As it is given in the problem statement, we'll eventually run into the combination of two numbers whose sum will be equal to the target. I hope you were able to understand the three scenarios. This solution works because of the fact that the array is sorted. That is why we are able to increment or decrement the values of the left and the right pointer to adjust our total and get it closer to the target. Let's do a couple of simulations to understand how will this work. To start with, left will be pointing at the first number and the right will be pointing at the last number. So the corresponding values will be 0 and 3. We'll use the 0 index values for now. Calculating the sum of the two numbers, the total is 17. As the sum is greater than the target given to us, we'll decrement the right pointer. So for the next run, my left will still be 0 and right will become 2. So for this run, my left is still pointing at 2 while right is pointing at 11, giving me the total of 13. As 13 is equal to the current given target, we'll stop the iteration and return left and right index. With this solution, our time complexity is improved to O of n as we are only running one iteration across the given inputs array, and the space complexity is just like before, O of 1, that is constant space. I hope you were able to understand this explanation. Let me show you how we can implement this using C#. Here is my C# solution. I start by initializing my left and the right pointer and start a while loop until left is less than right, and then calculating the sum that left and right pointers are pointing at. If the sum is equal to target, which is case number 1, I stop the iteration and return the output. If sum is less than target, it means I need to use a bigger number from the left hand side. So I increment my left pointer. In the last case where sum is greater than the target, I am decrementing my right pointer so that we replace the bigger value with a smaller number. This code, when submitted on LeetCode, beats 100% of the submissions in terms of runtime and 20% in terms of memory. Thank you for watching this video. I hope you were able to understand the explanation. The link to the code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.